This is problem 74 of Neetcode 150, Palindrome partitioning. So we are given a string S, and we have to split S into substrings, where every substring is a palindrome. So palindrome is basically a sequence of characters that, if reversed, are exactly the same. So for example, kayak is a palindrome. So we have to return the solution in any order. The example one that they gave us is a string containing A, and B. And we can see that with this string, we can have A, we can have a single A as well. We can have B. We can also have another solution which contains double A and one that contains single B. Notice that we have to consider the order of these characters. Right, so we can't say ABA because ABA will be a palindrome, but they don't appear in this order in the string we're given, so we have to take this in consideration. So with that being said, let's jump into the example. So I wrote here a function. So backtrack is going to be the algorithm we're going to use. So we're going to use backtracking with recursion. So you can already know that we are going to use sort of brute force approach. So our solution is going to be of a time complexity of 2 raised to the n, and we have to actually use recursion for every single character. So it's going to be equal to n times 2n. There's not a better way to do it, so this is the most optimal solution. All right, so let's read this function here. So we have our function backtrack, and we have a parameter called rem, which means reminder, and also path, which means basically what we had so far. So what we had so far could more concretely mean like A, or double A, or B, or just AB. All right, so after this, you can see a for loop where we are looping for I in the range of 1 to the length of the reminder that we're given plus 1. Reason is that we are going to be willing to check every single value starting from the first one. For example, if we take AAB here above, initially we are going to be willing to check A alone. So this is why you can see that we start with an I of 1. So when we say if rem starting at the first index and bounded to the right at the index I, it means that I is not included. So it basically means that we start at index 0 and we don't include index 1. So that will just give us the first index itself. So it's going to be A. So after this, on the second while loop, we are going to go see a rem bounded, well, starting from index 0, bounded at index 2. So we are going to have A and A. Okay. And we're going to check if this is equal to the reverse. Okay. So this notation here, so the double columns and -1 just means reverse the string. So if this is equal to the reverse of this reminder, well, it means that we have a palindrome. And every time we have a palindrome, we are going to use a backtrack function. So let me show you how to visually see that. Okay, so let's start with what we have. We have A, and B, and we're going to say for I in the range of 1. And at this point, reminder, the reminder is going to be AAB. Okay, because initially we are going to call a backtrack function, and we're going to set the reminder to basically the string that we're given, right? And the path is going to be an empty path initially, which makes sense. So on the very first call of this function, we're going to go for I in the range of 1, and then the rem is going to be 3, so 3 plus 1 is going to be 4. All right, so we're going to initially start, and we're going to take just the first characters. It's going to be starting from index 0, and it's going to be bounded at index 1. So basically, we're just going to take the index 0. And is this going to be equal to the reverse of the string? Well, a simple character reverse is still that simple character, so yes. So we're gonna call this function backtrack, and we're gonna set the reminder to to basically to the rest of this string. So you can see here we're going to start at the index I, which is 1. So we're going to go um, see the rest of the string, and let me show you how this is going to be done. So let me just copy this because we're using recursive calls, so um, the function is the same. All right, so when we call rem starting at index I up to the n, knowing that our index I is 1, we are going to start at the index 1. So index 0, well, you're done. Okay, so this is the second recursive call. And let me just draw it so you can like visualize it. Okay, and here I is going to be 1. And we're kind of like freeze at this state where I is 1 until the recursive call climbs back to this surface level call. Okay, so here again for I in the range of 1 and the length of rem, which is going to be 2 at this point, plus 1, so 3. So we're going to initially start with an I of 1 as well. So this is like this is the first check for every single call. So we are going to check if this if the rem at the index starting 0 up to index 1 is equal to its reverse, and you can see that yes, because we have a, so a itself is going to be a palindrome, right? It can be inversed. So hopefully my drawing skills won't be too bad this morning. So you can see that on this on this if statement, we have a true. So we are going to call again a backtrack function, and we are going to start the reminder at the index I, which is still index 1, but at the index 1 of this reminder. So we're going to send only a b in this next recursive call. Okay, and we have a and a now because we added to the path, which is initially empty, the reminder. So we have this, and now let me call this again. So we are gonna go over that. All right, and let me just go down a little bit. Okay, so all right, we are here, but this time notice that we only have a b, right? Because on every recursive call we send the reminder to be whatever the value is, but starting at the index 1, so the index 0 is out. And once again, we are gonna have our index I set to 1 initially, and we actually won't be able to go any much farther than that because there's no indexed index 2. Well, there's no index 1 as well in this case, right? We only have a single value. So we're going to check if that value is equal to this reverse. And yes, right, b itself is going to be equal to its reverse. So we're going to add this to the list. So we're going to have now our, well, let me just copy what's above. All right, so we're going to have this. And can I make this? No, okay. Yeah, so we're gonna add a b to that. Cool. All right. And now what do? Well, we are gonna call this backtrack function again. But we're gonna send actually a reminder empty, right? Because there's nothing left once we take that index 0 out. Okay. So we have to make sure that in our function we take this into account. So if the reminder is empty, well, this is our clue that we arrived to the end of our call. So we have to return. So here there's nothing. So we are gonna have to write a first check. So if there's no rem, just like return. So we're here, and now we're on our way back. So let me pick another color. So now we are on our way back. Okay. But actually, when we go back one, we see that the for loop is basically over, right? Because there's no other value we can reach after the index one. So we're gonna keep going the for loop, but there's nothing left. So we're gonna go see by default index the reminder up to bounded to index 2, but it won't work. So there's nothing we're gonna do. So we're just gonna go back one level, and now notice that at this level AB, we are still freeze at the I equal 1. So when we go back to this, actually, it's like if time froze for this example. So instead of 1, well, we are already going to go see I2. And I2 is going to be equal to this, right? Because the reminder is going to be starting at index 0 and it's going to be bound at index 2. So it's going to include index 1 and, well, index 0 and 1. So we're going to go see if AB itself reverse is equal to AB, and it is not. So we're not going to backtrack on this at all. So we're just going to keep going our return call. So now we're going to go back here, and once again we are frozen in our state where the I was equal to 1. So we keep going. We see I equal 2. So now we have the reminder, which is this here, bound starting at index 0, bounded to index 2. So it's going to include index 1 and 2, which is AA. And AA reverse is also AA. So we are going to add a recursive call on this again. And it's going to go down, and we'll see that eventually there's no path. So there's no need to actually delve into this. So let's just say that we then go to index 3. So I is equal to 3. And we are going to reach AAB, but AAB reverses BAA. So it's not a good palindrome. So yeah, so notice that we actually added our a B. We also added AA. So we have actually all the possibilities by using this function. So let's go ahead and actually define our function backtrack. And in this backtrack, we want to pass the reminder and the current path. And now we want to check if the reminder is empty, right? So if we pass nothing to it, we are going to append the current path, and we're going to return. So we're going to say if not reminder, we are going to say self dot, and now I have to define the result, but let's say that we defined the result. So we're going to say self dot result, and we're going to append to it the current path that we had, and then return. And this also makes me think that we actually have to define this res somewhere. So let's define it under it. So we're going to say self.res is equal to this. And we are also, after we define res, we are going to call it backtrack. So backtrack, and we're initially going to start the reminder with S, which is the string that we're given. And we are going to start with an empty array. All right, and we're going to return self.res. All right, now we can create the function. So we made our return statement. And now this is where we create our loop. So we're going to say for I in the range starting at 1 up to the length of the reminder plus 1. So here we are going to have the same same exact code as what we had in the whiteboard. So we're gonna take the reminder, bounded at that index I, and this is if this is equal to the that same string inverse. So rem also starting at index 0, bounded at index I, and we have to also say double colon -1, so we reverse the string. So if this appears to be true, this is where we are going to call again backtrack. But this time we're going to pass the rest of the actual reminder, which is basically going to start at index I and go up to the n. And the path that we have is going to be the current path plus that value. So reminder rem starting at the index 0, bounded at index I. Okay, so this is the entire code. It's quite short. Should work on theory. Let's see that. And yes, awesome. So I hope you learned from this video, and I hope to see you in the next one.